Hi everybody. In this question, we have a cuboid given here, and we're told that A to D, so this length, is 9 centimeters. F to D, which is this length, is 13 centimeters, and angle G to H to F is 49 degrees. We need to work out the size of angle FAH, so F to A to H, this angle here. Do you want to give this question a go yourself using right angle triangles? So that will be trigonometry and Pythagoras' theorem. You can pause the video, and when you come back, you can check your working with mine. Okay, so welcome back if you want to go. So with questions like this, the first thing we need to do is we need to identify right angle triangles. And we need the triangle to involve angle F to A to H. So if I show that on our 3D shape, then you can see our right angle is at F. We have this horizontal surface and this vertical surface. Now it's much easier to sketch this as a 2D triangle rather than trying to include all the information on this diagram. So if I label these vertices as F to H to A, we know A to D is 9 centimeters. That's this length here. We know F to D is 13 centimeters, and F to D is this length. And then GH to F, which is this angle here, is 49. So I'm going to use that to work out the green angle. That'll be 90 take away 49, that'll be 41 degrees. Now the first thing we can do is we can work out the length A to F, and that'll be this length here. Because we have this right angle triangle, we can use Pythagoras with the hypotenuse and the length A to D. So I'll sketch this as a separate right angle triangle. The right angles at A, from A to D is 9. The hypotenuse is 13, and we've got angle F down here. So using Pythagoras' theorem, A to F squared plus A to D squared will equal the hypotenuse squared. So we can take away the 9 squared from both sides, and we'll get 169, the 13 squared, minus the 9 squared, minus the 81. So A to F squared will be the square root of 88. And this works out at approximately 9.38. So that'll be this length here. And I can include that on my blue triangle, 9.38. Now I can use this 41 degrees with this length because we know F to E must be the same as A to D. So we can write this as 9 centimeters as well. So now we can use this right angle triangle, and this will allow us to work out F to H, which is this length here. So if I sketch this green triangle, the right angle is at E, angle H we know is 41 degrees, and the opposite side is 9. And we want to work out the hypotenuse. This is F to H. So because we've got the opposite and the hypotenuse, we're going to use sine. So the sine of the 41 degrees will be the opposite over F to H. To work out F to H, we'll move this over to the left-hand side, and then we'll divide both sides by the sine of 41. So F to H will be 9 over the sine of 41. We can work this out, and we get approximately 13.72. So now I can include this length here on this diagram, 13.72. So now we can work out the size of the angle F to A to H, which is this angle here. Again, using trigonometry, because now we've got the opposite side, which is 13.72, and we've got the adjacent side. So we'll use tan. I'll call this angle theta. So the tan of the angle theta will be 13.72 divided by the 9.38. We'll take the arctan of both sides, and when we work this out to the nearest degree, we get 55.6 or 56 degrees. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on trigonometry with 3D shapes, you can download the lessons and the worksheets from my website, mrmathematics.com. I'll leave a link in the description below.